Hello everyone, I am Mansi. I'm from Department of CSCAI from Sri Venkateshwara College of Engineering. So today's topic is implementation and demonstration of Q-learning algorithm. So Q-learning algorithm, it comes under machine learning and deep learning. So let's begin with this video. So in this video, I will talk about the introduction. What is a Q-learning overview? What is Q-table? The basic Q-learning algorithm. What is off-policy learning? And Q-learning example, convergence and optimality, and application of Q-learning. So let's begin with an introduction. So reinforcement learning is an interdisciplinary area of machine learning and optimal control concerned with how an intelligent agent ought to take an action in a dynamic environment in order to maximize the cumulative rewards. So, what are the basic components of reinforcement learning? An agent, environment, actions, and rewards. So, a reinforcement learning model has four essential components: a policy, reward, a value functions, and environmental model. So, what is Q learning overview? So, explanation of Q learning as a value based reinforcement learning algorithm. So, Q learning is a model free of policy reinforcement learning that will find the best course of actions given the current state of agent. So, it uses Q values to iteratively improve the behavior of an agent. So, Q learning uses Q values to represent the expected cumulative rewards to take a particular action in the particular state. So what is Q table? So building a table of Q of S comma A values. The Q table is just a lookup table where we calculate the maximum expected future rewards for an action at given states. For each states. So initialization and update of Q values based on agents experience and behavior. So to learn each value of Q table, we use Q learning algorithm, which involves an iterative process of updating the values based on agents' behavior and action. So, what is a basic Q learning algorithm? So, description of key steps of Q learning algorithm are as follow. So, Q learning is a model-free reinforcement learning algorithm to learn the value of actions in the particular state. It does not require the model of an environment and can handle problems with stochastic transitions and rewards without requiring adaptations. So, exploration and exploitation phases. The Q learning algorithm involves a balance between the exploration, that is, trying new actions, and exploitation, that is, choosing actions based on the current knowledge to find the optimal policy. So, what is off policy learning? So, explanation of Q learning as an off policy algorithm. So, Q learning takes an off policy approach to reinforcement learning, aiming to determine the optimal actions based on the current state. So, the agent's ability to learn Q values regardless of policy being followed. So, the Q learning allows the agents to learn Q values independently of a policy being followed, which contributes to its robustness and flexibility. So, what is a Q learning example? So, step by step illustration of Q learning process in a simple environment. And a Q learning example can demonstrate how an agent learned to take decisions based on Q values, association with the different actions in different states. So, initialization, action selection, and Q value updates. So, the Q learning process involves initialization of Q table, selecting the actions, and updating the Q values based on the rewards received. So, what is convergence and optimality? Yeah. So, convergence and optimality, the discussion of convergence in Q learning. Q learning aims to converge to optimal policy by iteratively updating Q values based on agents' experience and rewards received. So, the goal is maximizing the Q values to find the optimal action selection policy. Yeah. So the ultimate objective of Q learning is to maximize the Q value for each state action pair to determine the optimal action selection policy. So what are some of the applications of Q learning? So Q-learning can be used in real-world applications such as game playing and robotic controller. So Q-learning has successfully applied in various real-world problems, including game playing, robotic control, and optimization tasks. So success stories and challenges in applying Q-learning to a complex problem. While Q-learning has shown success in many domains, it also presents challenges such as scalability to large state, space, and complex environment. So thank you for watching the video.